Hello everyone, welcome to our third R lab. It is our last lab session in our course, and the topic is correlation and regression. Firstly, the aim of linear regression is to model a continuous variable y as a mathematical function of one or more x variables. So in our course, we only cover simple linear regression involving only one predictor. But if you are interested in linear regression, you can take EPSY480 for more information. So here is our example. We want to use weight to predict height, and it is the data set. Firstly, we want to compute the correlation between two variables. We simply use COR, the correlation function. And then we can see our Pearson correlation coefficient shown in the console, 0.977. It shows that there is a strong positive relationship between weight and height. And secondly, we want to construct a regression model. Our null hypothesis is that there is no relationship between weight and height, which is same as the slope of the regression line is 0. And we use LM function to construct our model. We put height, our y, here, and weight, our x, here. We store this model in rec model. And we use summary function to call out the result. So in the console, we can get the result of this regression model. So the estimated intercept is 61.380, and the estimated slope of weight is 1.415. Both parameters are significant because we can see here the p-values are smaller than 0.001, showing that they are significantly different from 0. Afterwards, we can get the F statistic of this regression model. It is 168.9. The degree of freedom is 1,8, and the p-value is smaller than 0.001. It means that we need to reject the null hypothesis, and the slope of the regression line is significantly different from 0. Besides, we can calculate R-square using squaring the correlation coefficient. This is R-square, 0.9548. And actually, the summary of the regression model also gives us the R-square in this line, the multiple R-squared. It actually shows the same results. And it represents that 95.48% of the variance in in height can be explained by weight. And finally, we want to plot the regression line. We use the plot function. So this is our x, this is our y. This is the blue. Blue means that we want our points to be blue. And the title is height and weight regression. So these two are actually other parameters that we can control. And this is the x-axis, this is the y-axis. Also, we use the AB line function to add the regression line into the plot. So this is the plot we get. And the line is the regression line that we estimate from our model. And the final thing is to add a text on this plot to show the detailed estimates. Here, we use the text function, and we run these three functions simultaneously to get all of them into one plot. And 80, 150 is actually the position of the center of this text. So these values are actually changing based on different scales of the x and y. So be careful to select the appropriate position in your own dataset in your research, and also in the exercises. So here we can see like this text actually shows the intercept and the slope, the detailed information of this regression model. If you are interested in the plot function, for example, what does CEX mean, what does PCH mean, you can always go to the help center to get more information. Okay, so these are the topic that we will cover in correlation and regression. This is the last part of information that we will need for our final project. And I hope you guys can plan your time to finish the final project. And thank you and good luck.